let's just continue. Welcome to the event streaming with KSQLDB, and this is what this chapter is all about. So after this module, you'll be able to use KSQLDB to filter, transform a stream. You'll be able to write a KSQLDB query that joins two streams or a stream and a table. Write a KSQLDB query that aggregates values per key, and then write push and pull queries. And we'll talk about these, like what does it mean, push and pull queries, and give you some idea of what it means from the API, okay? Or just in general. And then, so let's look at this. What is KSQLDB? As we look at the traditional, like the common architecture, as the people would say, when people are doing streaming, you're bringing the data into Kafka, and then maybe you're doing stream processing, and you can see this whole picture. This is what people would do. Stream processing, what are you using, whatever architecture. In this picture, you'll see that, for example, Spark is here in this top right-hand corner. You say, well, what does that really mean? For example, in the big data world, when we use Spark, like if you were using a Hadoop Cloudera platform or something like that, and you have Spark included as part of the architecture, Spark still did not have a way to bring the data from like the database into Spark, right? If you're doing Hadoop, in HDFS, they have a product called Scoop. And Scoop allows you to connect to the databases, and you can import the data into the Hadoop cluster, right? So Scoop, S-Q-O-O-P, it's a very simple, well, not very simple, but it's the equivalent of the connectors in the HDFS world. And then once the data is in HDFS, you could do Spark processing. Spark could process the data in its memory, in executor, right, in the executor. But that still is not real-time data coming into Spark. So what people would do is, if you notice, Cloudera added like Kafka into the platform, and Kafka was used as a source of streaming data to Spark. And then Spark would have a receiver to receive this data, and then would send it to the Spark nodes in the cluster to be able to process the data in the executors, right? But so you'll see a lot of these platforms, Flink, Stone, other places using something similar, but Kafka has been the backbone for many, many companies doing all of these things, right? And now it's like, okay, well, over time, we have evolved, and we can do lots of different things once the data is in our own Kafka cluster. And we saw that before with Kafka streams, right? With Kafka streams, you have the data in your brokers, and you could do your Kafka streams applications to pull the data, consume the data, bring it into your topology, through transformations, and then write output back into Kafka. But we know that we had to do it in Java and Scala. And we didn't, and also the Kafka Streams application did not give you a way to connect to you didn't have connectors built into your Kafka Streams application. So you had to have, if you had database bringing data in, you have to use the Kafka Connect, right? Remember, we talked about that in previous class, which means I have workers, and the workers are running the connectors and the task. So I have multiple workers running in distributed mode, running the connectors and task. And these workers are doing the job of bringing the source connectors, are bringing the data into Kafka cluster. And then once the data is into Kafka cluster, then your streaming application takes this data and does whatever you need to do, right? But then the changes now with KSQL, before KSQLDB, you still had to have a separate connect cluster. But now with KSQLDB, you do not actually have to have a connect cluster. KSQLDB does this whole, it has connectors built in, right? And it's very, very powerful. You can have the connect cluster, or you don't have to, but it does the stream processing. That means processing the data in real time. You don't have to write Java or Scala. You just have to understand basic KSQL, which is pretty much like ANSI SQL. It's very similar, right? And it works, you can work with materialized views, and all of these things we'll see. So you can still bring the data in, process the data, and of course, remember, the true source of everything that you produce and work with will end up in Kafka, right? So this is important to understand. But KSQL DB, or yeah, they show the Kafka cluster on this end. But it's changed. So the whole point to all of this is, right, it used to be called KSQL before, but as of 5.4 release, they renamed it to KSQLDB, right? And that's available to you. You can use it as a community license. You can use it without having to pay for it. And they introduced this concept of a poll query. We'll talk about that as we go through this course. So KSQLDB is very important. We want to make streaming applications basically simple for everybody to use and make it easy. And you will see this, like I said, in many different frameworks. Even Spark itself does something called structure streaming with SQL-like syntax, right? So this is what KSQL, I'll talk more about KSQLDB as we go through this. But for now, here's the picture of your Kafka cluster. Remember, these are your brokers. Kafka cluster is always your brokers. And you notice here, you'll see like this is 1, 2, 3. It looks like 3. And notice they're saying KSQLDB servers. You're probably wondering, well, where are those? Well, you have your Kafka cluster. I'll just do a separate picture here. Here's your Kafka cluster. These are my brokers. If I want to run KSQLDB servers, I could spin up several instances here like this. And you should see a familiar pattern, just like consumers within a group, or just like Kafka Streams applications with the same application ID, or just like workers, as we just saw in the previous chapter, when you're dealing with distributed mode and you have the different workers in the Kafka Connect cluster, right? I can have a group of KSQLDB instances, and they all run with what's called the KSQL service ID. So if you give it a KSQL service ID, so I just said KSQL service. So if it has the same KSQL service ID, then they all work together. So this could be another cluster of KSQL servers, and it will run with the different KSQL service ID, just a string. Let's just call this one, for example, XY, and this one is AB. Again, these names may make no sense, but I just want to tell you. So when I submit a job, if I have different ways to access through the command line or through the UI, as you can see here, when you're going through the control center, you're basically underneath the hood, you're still connecting through the REST API to be able to communicate with the KSQLDB server, right? And then you'll be able to run those queries. So when you submit a job to like this KSQLDB cluster, this is considered the B1 cluster. This is another cluster if you have separate clusters. If you submit to this, then the instances here are the ones that use the CPU and memory to process the data that you are working with in Kafka, right? And you may wonder, well, why do I need to do different clusters? Because in Kafka, as in some other environments, like if you are familiar with some of the distributed systems like Impala or some of the frameworks, where a user can write a query, but I can restrict a particular user to say, okay, this user is going to write a query, but I want to make sure this user does not use more than 50 megabytes of memory and no more than, like so many, let's say 1 core of CPU, I want to restrict the user query to a certain amount of resources. On some frameworks, you can do that, but in Kafka, if you have a user using a particular cluster and they write a really expensive query, they could consume the resources from other users. And so you may have someone complaining, hey, this Kafka KSQL is slow, but it's not really slow. It's just that this person is doing a lot of really expensive stuff like aggregations and joins and stuff like that. And so it makes the cluster, they're taking up resources from other people. So what people do sometimes is create separate KSQL clusters with different permissions or different resource. And I know they're working on ways to make this a little bit better. There's some things that have been added more recently, but for the most part, just know that when they say KSQL cluster, it's a collection of these things, just like we saw with the workers in connectors. So you have your Kafka cluster, you have KSQL, and the whole point is I want to be able to submit a query to the cluster, and I want these KSQLDB servers to be able to execute this on the data that is in Kafka, right? And then I want to be able to do this without having to write any Java or Scala. And note that at a very low level, or let's say at a high level, if I write KSQLDB queries, they compile down into K-streams. And from K-streams, we know that K-streams have both consumers and producers, right? So this is the level of, this is the lowest level here, this is a high level, and this is a very, so it's pretty much the same. These KSQL DB queries will compile to Kafka streams. Essentially, everything we learn about Kafka streams applies, like the state and everything else, because it's really a Kafka streams application, right? So it's really a Kafka streams application. It's just that you're using SQL to do this. Okay. So very important. It has all the scalable, fault tolerant, has all those features that are built into it. And then example use cases, lots of different things you can do with it, right? Data exploration, filter cleaning, masking, just like you would do with, if you could think about it in SQL terms, you can do it with KSQL. As a matter of fact, probably close to 90% of your pipeline can be created with KSQL without any problem. So if you ever wonder, hey, is this something different? Is there some performance difference? No, because remember, it compiles to a Kafka Streams application. So it's the same thing. You just have a shorter time to development. You can be up and running real quick. You could probably do a lot of quick use case, come up with a lot of scenarios really quickly. And you'll see some examples of the code. If you understand basic SQL, you will feel right at home. And that's the good thing about this. So these are a few cases here: anomaly detection, streaming ETL. And when this is streaming ETL, right? Because we're doing extraction, transformation, and loading. So what does that mean? Here's the database, for example. I'm bringing the data in from the database using Kafka Connect. But this is like the extract. And it's coming now into Kafka cluster. Here are all the brokers. This is my Kafka cluster, right? I just Kafka. And then I can do transformations with KSQL or K-streams, right? Doesn't really matter. And that's the transformation. That is the part that is the T transformation. And then I can load the data using connector to an external environment, wherever, like Elastic. But this is the L composition. So you can literally do ETL with the concept of extracting from a source, loading it into Kafka, doing transformations with KSQL or DB or K-streams, and then loading it with connectors into an external environment. So full ETL can be done with Kafka. Then we want to look at some basic code, right? And if you're familiar with SQL, if you've had a class in college or at some point, this would be familiar with you, to you, right? We have like the CTAS, let's say create table as select. So we also have in Kafka, this is in the database world, but this is also in Kafka where we say create streams as select, right? So we have this one in Kafka as well. But now it says, look, create a table. The table name is possible fraud. And say, okay, well, what do you want to have in the table? I want a card number, select the card number, and then do a count of those number records. And you selecting from an authorization attempt stream, pretend that there's an authorization, I'll say AA. So pretend that there's an authorization attempt stream, right? And then window hopping, notice there's a hopping window. The size of the window is 5 seconds. So there's a 5-second window. And remember, hopping window, the advance by is 1. So the window size is 5. So every 1 second, when it advances, then I will get a new set of records that will be included, but I will lose the records that were before the advance. So these ones here will no longer be available. So my window size, so hopping window. So say hopping window, size 5 seconds, advance by 1. And I say group by card number. And if the count is, if it's greater than 3. So what is this really saying? So look, I want to create this new table called possible fraud. But what am I going to do? Look at the number of times that you have a field called card number that will show up in this stream called authorization attempts, because I'm selecting from this stream, right? From the authorization attempts, but I'm looking over a 5-second hopping window. So in other words, I get my output every second. If the card number appears more than 3 times in that window, then I want to create the message with the card number as the key and the count as the value, but that would be what's put into the table called possible fraud. Beautiful, right? You write this, look, there's just a few lines, if I were to ask you to do something like this with the low level, consumer code, I don't think it will be that easy, even for the best developers, right? It's not that easy. So a few lines, 5 lines of code here to maybe, who knows, how many, like 50 lines of code or something else in low level, in other API. So really, really easy and easy to figure out. So you have these kinds of statements like create, select, show, describe, just like in the database world. I create the streams. Notice I can create streams or tables, right? Connectors and other things. Select, create push or pull queries. We'll talk a little bit. In this class, we don't give you too much. Martin says, sorry, can you repeat the window hopping part? Oh, sure. I looked at it and all of a sudden I saw the question at the end. So the hopping window, you're basically saying, let's say I decide a window size. And in this case, it's very easy to declare it when you're using SQL as opposed to using K-streams. But I just say, look, my size is 5 seconds. That means that's the window. That is the window size, right? Consider the size. And then, so in this case, let's say it's 5 seconds. Remember, that could be 5 minutes or 5 hours or whatever. But a hopping window is just like a tumbler window. If I said 5 seconds and I didn't do advanced by, then it would just be a tumbler window. So then what that means is look at all the records coming in. How many attempts did I get in this 5 second window? Then I could say 1, 2, 3, 4, 5. Let's put another one, 6, 7. So let's say I could say, okay, there's 7 attempts. Pretend that each of these squiggly lines is an attempt. So I could say, okay, in this 5 second window, this. But then if I say advance by 1, so every 1 second, this now, let's say this at this point, this is like the 5 second mark. Then when it goes to the next one, I advance by 1 second. That's the advance by. I will no longer get these records on this side, right? Because I will lose 1 second here. So no longer get these records, but I will get a new set of records coming in. So maybe in this time frame, right? I'm looking for a particular card number to see how many times it occurred. And maybe that card number occurs only 1, 2 times because it doesn't appear year, or maybe it's just, or maybe it's 3 times, maybe there's 1 in year. So 1, 2, 3. But the window will be over this. So there's 3 times here. Then when it advances to the next, again, I lose a minute on this end. I lose a second on this end and gain a second on this side, right? So now, yeah, awesome. So it's like, that's what they call hopping window. And then there's overlapping records. There's a possibility that the same record you're looking for will appear many times, or maybe not at all. So within this 5 second, let's say if user marking this 5 second window, I only have 1 record for user marking, right? And then the next second goes by. And then now at this point, from year to year, I lose, this is no longer a year. This will be no longer available, but I would gain once on this side. Then now at this point, imagine that there's 3 attempts for marking. So then my total now for this output is 1, 2, 3, 4. So it's 4 at this point. And then when it slides again, then let's say I lose this second, right? Then maybe there's nothing, no attempts coming at this point. So then my total for this time is 1, 2, 3, only 3, right? And it's really interesting. So anyway, but you have these methods here. So then KSQL DB functions and clauses, there's many popular scalar functions, just like in the database. We have absolute values, ceiling, concat, length, round, trend, substring. A lot of the basic functions you're seeing in the database world. And you guys probably, some of you may be excellent at using, working with the database, and others maybe not. I know for many years, I avoided working with databases because I didn't want to get siloed into losing my programming or operating system skills. So I would always avoid database projects. But when I got to Cloudera 2013, there was no way. I started to work with MapReduce. I had to really become a big fan of it. And now I am If you can beat them, join them. There's no going away from SQL. So you have to get more comfortable with SQL. It's always going to be here. There's been a lot of research, just to let you know, over the last 30 years or more on SQL. There's a lot of good research in computer science field on SQL and the mathematics behind it and why it's such a standard. So it's not just something that is a fluke that is going to go away. So I would suggest that, it's one of those things I would say today, in today's technology, today's world, you really should learn SQL. It should be one of your tool sets, one of your tools in your toolbox, I should say. So joins, you can join, do aggregations. If I want to rekey the stream, what does it mean by rekey the stream? Remember, I have a stream of data coming in. Here's the keys to customer ID. And it has, the customer has a name and date of birth and salary and maybe address and maybe social security number. So maybe this time I'm using customer ID as the key, but I want to rekey this stream so I can use the social security number as a stream, right? You can say partition by and then give the column name, which is really cool. It's a great thing. So I can decide what my new key is going to be. And then the rest of the record will be my value, right? So it's really powerful in SQL to do these kinds of things. And you can also say partition by, the resulting stream will have a new key set by some UDF. I said, well, what is a UDF? Was what they call the user-defined function. So pretend that you are working and you are currently using standard SQL, or maybe you've used to work with Oracle, PL SQL, or SQLite, SQLite, whatever you want to call it. And you knew some really amazing functions in that area. And then you come to KSQL-DB. You say, hey, Hussein, I used to do this in SQL, and I see that KSQL-DB doesn't have it. When you guys going to have it? I'm not really sure. Let's talk to engineering. But then you say, I'm a great developer. You go ahead and you decide to write your own function. This is what they call the user-defined function. So user-defined functions can be pretty useful. You write it in Java, and you can make it available to your KSQL application, KSQL-DB server, to be able to use this, right? So this is something that I think is really, really powerful. So when I say UDF, you apply, so think of it this way. You apply to a single row, and then you can emit a single row, right? And just imagine that you're working on a single row, you emit a single row. Or it could be a user-defined aggregate function, for example, right? So let's say you get a set of rows in this case, and then you give out an output, right, that results from the set of rows. So like doing a sum or a count, right? So something like that. Or you could say the UDTF, user-defined table functions, right? You get one input row, and then you can give out multiple rows, just like nesting an array, right? So this is the kind of stuff that you can do. But the whole point to this is you can write your own function in Java, and you can make it available to your KSQL-DB servers. Really simple to do, few steps. You just put it in like a /ext directory, and you restart the KSQL-DB servers, and then they will know about their functions, and the function will be available. So the whole point to this is you guys will see that it's very useful, and you can write your own functions. So if it doesn't exist, you can write your own. And then this comes back to what we talked about when we did KStream. So remember, a tumbling window is a fixed size. If I say I want every, let's say 5 minutes, then any of the records coming in within this 5 minutes time, let's say I want to count the number of times that this login, a particular user had a login failure within a 5-minute time frame. So every 5 minutes, I want to see the login failures, right? So within this 5-minute window, you can get per user, per key. I look at the number of times the failures occur. And then, so let's see if it goes from 12. I did this before with the KStream, so we'll do it again real quick. 1205. So I include only here. So the tumbling window is non-overlapping. So at 1205 begins the new window, and then it will go to like 1210. Then my aggregations are only for the records that are coming in this time. Only the records coming in up to 1210. and then maybe my output is maybe 4 or something, or 5, whatever. And then the next window begins at 12:10 and then goes to 12:15. So the tumbler window is pretty simple. And then a hopping window is exactly like the tumbler window, except that you specify in advance by, right? How you want to move. And then, of course, we talked about session window before as well. Session window, you're looking at the key, the timestamp, and you're deciding, you set the time, like if your session say how long can this, is this period of inactivity before the key needs to be put into a different, before you have to put it into a separate window. So session windows can be very useful, right? Sessions with periods of activity and gaps in between. So, but these are the 3 windows we talked about before in the Kafka streams, and it's very easy to implement them when you're using KSQL. So when you're working with KSQL, you also want to be comfortable with the concept. When they say non-persistent query, that means the result will not be persisted in the Kafka topic. So for example, when I do a select statement, I'm just doing a query, just will come to my screen, right? To my console, no big deal. Some people say transient because it doesn't store anything in Kafka. But when you say persistent query, that's like when you create a string or say create table as select or create stream as select, the result will be persisted in the Kafka topic. So this is just giving you some terminology. They'll say this is what a persistent query looks like, and this is what a non-persistent query look like. Then this part, you say, well, what is a, how do you call this? A pull query, right? So when they say pull query, this is really useful. And this is what you guys are actually more familiar with in the database world, right? Look up a current value from a materialized table, and then a single response returning HTTP request. Again, this is just textbook type definition, but the whole point is when you're dealing with pull queries, these can be very, very, it's just like it's more of what you are currently familiar with. So just keep that in mind. It's what you are familiar with. If you say, what I've been working with. So select star from views where user ID equals this, and this is just specifying some number less than equal to window start and window start. So this is not the best example in the world, but a pull query, you are going to receive the result that looks exactly like now, like the snapshot in the database, right? So this is what you are familiar with. They're good fit, like they say, for any kind of synchronous control flow. But the push query this one is really interesting. So you are subscribing to a string, and in Kafka or KSQL DB, you do have to say emit changes. This was not always this way. Like I said, select star from table, and then I say emit changes, right? This is something that I forget what release we added that, but it's still a little bit unusual for most people who've been using SQL for a long time, but just know that you need to put the emit changes at the end. Okay, so push queries can be very useful, like if you're dealing with microservices, real-time applications, or any kind of asynchronous control flow. That's what they're referring to. And we give you some notes about this in the definition. The point is, just think of the pull query as more as what you're familiar with it, like a real-time snapshot of what's going on. And a push query is one that you can subscribe to. Okay. And you'll get more familiar once you start looking at the examples. But here's an example now. Look at this. I say create streams and tables from Kafka topics. If you remember from the Kafka streams chapter, we use the stream builder class, right? We say stream builder, and we said builder, and we said assign new stream builder, and then we said builder.stream. When we say builder.stream, we say, look, and we give it a topic name. That's when we bring in the data record by record from that topic into a source processor, right? And then into a topology and do our transformations. But now with KSQL, look what I have to do. Very simple. Create stream. I'm saying I want to create a stream, and the name of the stream is page views. PAGEVIEWS. So I want to create a stream called page views. And it says, and I'm specifying view time would be big int, user ID would be varchar, page ID would be varchar. And it said the value format is JSON. See, specify this. And the Kafka topic is my page views topic. So this is an example, just like you have done before, but in this case, I'm telling you, I'm creating a stream, and this is where data is coming from. And then I can say create table, just like we saw builder.table, but this is now create table, the name of the table. So I have a users table. So there's a users table now, and there's a page view string. So it's a string, and there's a table, right? And again, value format is this, and a Kafka topic is my users topic. And hopefully that my users topic will be a compacted topic, right? It doesn't have to be, but if you're working with tables, it's good. So now I have create stream, create table. I know how to create a stream and a table. Very easy with this. And here's an example now of doing a join. So I remember I have the page view stream like we just did before. I'm going to say PV for page views. That's a page view string, and I'm going to say U for users table. Remember, this is the users table, right? And this is the page view string. So what do I want to do now? I say, look, create a stream called page views enrich, and I'm going to use the acronym PE. I want a new stream called page views enrich. And it says, okay, what goes into this stream? What do I put into this new stream? I say, I want you to select the user ID, and I'm using an alias here, PV. So the user ID from the page view stream, and that will be displayed when you say as, that's like alias, right? So you will have the user ID, then I want to have the view time from the page view stream, and the page ID from the page view stream, and then the gender from the users table, and a region ID from the users table. And notice when I say select all of this, and I say from page views, PV. So I'm selecting, making selection from this, and I'm doing a left join on the user. So that's like saying page views dot join dot left join on users. If you were writing Kafka streams, it'll be something like page views dot left join users, because notice the page view is on the left-hand side. Page views come first. And I say left join the users. And then what is the join condition? I say the join condition is where the user ID in the page views is the same as the user ID in the user tables, right? That's the join condition, right? So if the user ID, then what I want to do is take that information and put it into this page views enrich string, which will have all this information as long as the user ID in the page views is the same as the user ID in the users table. Okay. And the left join says that when you see a left join, the key you're looking for needs to be on the left-hand side. And if you have the matching records, if you don't have the matching records on the right-hand side, then you end up with null. But the left join expects the key to be on the left-hand side. So that means this is the left-hand side. This is the right-hand side. So whenever, just think of it like this, A.join B. Whatever you put before the join is left-hand side. Whatever you put after the join is the right-hand side. And whenever you see a statement like you see in a SQL right here like this, just a quick review for those who may be new to it. Okay. In this case, when I say from page views, that's like the left-hand side, right? From, that's like, okay, my left-hand side right here. And then whatever kind of join. If I do not put left join, the default is an inner join. So if I just said join users, then it would be what's called the inner join. That means you need the key on both the left. You can have it on left side and matching on the right-hand side. So the inner join is the default. But I can also say left join, inner join. Well, I don't have to say inner, but I can also say outer join. So in Kafka, we do the left, outer, and inner. There's no right join in Kafka. But that's a perfect example of that. And then here's another one, doing a persistent query, like you see here with the aggregate. This one is a windowing example with this. So we create a windowed table called page views count by region. and it defines 30-second tumbling window size, as you can see right here. So 30-second and no tumbling window. That means I have a fixed window of 30 seconds, and I'm looking for all the events within this time. So I say create the page views, the table called page view count by region. And what's going to go into this table? I want to select the gender ID, the region ID, and I want the counts, but the count will be displayed as total. So when you say AS, this is for alias, so be displayed as total. But you're selecting from page views enrich. So let's say PVE for page views enrich. So this is considered to be the left-hand side, right? Because it comes first. And I specify the tumbling window, 30 seconds, right? And I say group by gender ID region. And in this case, I'm just selecting from, there's no need for left, but I'm just selecting from the page views enrich. And I'm specifying that I want to group by gender ID and region ID, as long as the count is greater than 1. So I said, look, the table has 2 columns, right? You have the names and you have the count. So the column containing the key value, let's say for each row, is system generated and can be determined using describe. There's some notes that you will see in your documentation, but just know that you're basically doing this over a tumbling window, and you're grouping by gender and then by region ID. I mean, gender and region, not region ID. And then you're counting the results. That's all you're doing. And SQL is pretty powerful. I mean, you can think about all kinds of interesting things to do. And that brings us to this point. Now, there's things, this is just an intro to this. In the 3-day KSQL course, we have a lot more that we talk about. And but this gives you a decent start, right? And so if you really want to pick up, I highly recommend that you start just playing with this, because you can be so effective doing a lot of things that even if you're the best developer, you could still be faster than the best developer in the world. I mean, yeah, the best developer will be able to do some amazing things as writing his own UDF and writing some Kafka Streams killer applications, but you can build greater than 85% of your pipeline using KSQL DB. So just to summarize this before we go to lunch, let's just make sure. Then we'll have like a lunch and lab combined, right? But to summarize this, remember, you have your Kafka cluster that you need to have, because within Kafka, you must have your brokers. So the brokers are always needed. This is, right? And I decide I want to use KSQL DB. Then I can spin up those KSQL DB instances, right? Just like we saw with like workers. But I speak up, it could be containers, virtual machine, physical machine, wherever I want to run the service. Just think of it as a service running. And then I can give it a unique KSQL service ID. I could also have another cluster with maybe 1, 2, 3 nodes. And maybe I could give this one a lot of CPU, each one a lot of CPU and a lot of memory. Maybe this is for my high-end users. So I want the engineering team to be able to use this, and I can have some engine. The KSQL service ID can be something that refers to engineering, and maybe this one's for the marketing team. Because I know this, I give this a lot of resources. So when you submit your job to the KSQL service, KSQL, that service ID, this one, then all these nodes here will be the ones to use their CPU and the memory to process your data in Kafka accordingly, right? And there's some things we're not talking about here about the command topics and stuff like that. But someone says, gang, he says, if we want to fully optimize our Kafka development, does it mean use KSQL as transformers and use Kafka Connect for the connectors? Oh no, you can use them both. Because remember, if you use KSQL DB now, it has the ability, because it has the built-in connectors. But you don't have to use KSQL DB. It's just that if you use it, it gives you that ability to do that. But when you're using Kafka, it's so easy to set up the connectors. So you can always have your connectors and don't have to worry about it. But it doesn't really affect it much at all. But when you're running your KSQL DB servers, what's going to be important is, understanding the resources you need. Because if you are a developer and imagine you're writing your query and your query is doing a lot of stuff like this, say group by, and you're doing count. So when you're doing a lot of aggregations or you're doing a lot of joins, right? So aggregations sometimes will take maybe 2 times as much resources as joins, right? And joins will probably take 2 times as much resources as something like when you're doing a select. So understanding that what kind of query you're doing, like if you're doing aggregations or if you're doing joins or you're doing select, you could be using a lot more resources in your cluster. So that means you should optimize your environment, yeah, for to be able to support what you're doing. And you should also be aware that we do not really impose constraints on a particular user, like say how much resources this user can or cannot do. If all the users are connecting to the KSQL cluster with the same service ID, then these instances in with the same service ID will work together to handle the load. And you'll see that the same fault, because remember, it basically compiles your Kafka Streams application. So imagine that each one of these things are like those Kafka Streams application with their state stores and everything else. So if one fails, you want the other one to be able to pick over the load. So when you think about optimization, you have to look into all those things that you know already about Kafka Streams. And you also need to understand that some queries are more expensive than others. And you need to also know that it's possible for one user to use a lot of the resources from others. So you may have to have separate KSQL DB clusters. And it sounds like a big thing, but it's just like connectors, right? We're just spinning up those instances, which is separate from my brokers. And hopefully that helps. But the whole general picture here is to say, if you're not a Java Scala developer, start with KSQL. It's very powerful. You're not losing anything by starting with it. If you can think about your solution in SQL terms, then go for it. Definitely. Because you're looking at 3, 4, 5 lines of code compared to having to write 200 lines of code. Ha! Which ones do? I prefer to write the 3 to 4, 5 lines of SQL. Select star. I mean, look at this. Look at how amazing this query is. You do something like this. Look at all the stuff that you're doing here, right? In this one query. And if you're familiar with SQL, you can think about it and write that. But do you know how long it would take you and how many lines of code to do that? Something else. Kafka Streams, maybe, you'll use maybe triple the number of lines. And then in other consumer API, you may use like 10 times the number of lines. So, yeah, but this is just an intro. And there, we give you lots of really great links to look at on the website. But I would say just start to run. And the important thing to understand, as we just mentioned, when you write KSQL program, it basically compiles into Kafka Streams application, right? KSTR. So your KSQL program compiles to Kafka Streams, and Kafka Streams runs with producers and consumers. So you're not really losing any kind of performance thing. It's not a separate entity that, I mean, it is a separate service. Remember, it's part of the community edition in Kafka. But now I will stop rambling and the lab for this time. So let me give you your time for lab. Sorry about that before I know some people are on the schedule. So with this in mind, we now have this chapter for KSQL. So the lab is 30 minutes as well. Oh no, actually the lab is 45. No, the lab is 30 minutes, sorry. So